Hope everybody's doing well. Okay. Where's my file? Okay. What kind of jersey is that? It's not a jersey. It's, well, I guess, I don't know. It's just like a t-shirt from whenever I lived in Taiwan. I coached soccer, and so my team went to this. Okay. So, yesterday we talked about binomial expansion and using Pascal's triangle, which is this lovely thing here. Using Pascal's triangle to make a binomial expansion, right? So if I wanted to do x plus y cubed, or 3a minus 1 to the fifth, 4x minus 3. So instead of having to actually multiply out all of that stuff, then we can use Pascal's triangle to more efficiently or more easily make the expansion. So that helps a lot. Actually, didn't come yesterday. Yeah. So the other way that we can do that is by using the binomial theorem, which is this. This is it's a bit grosser. This is kind of the more formal way to do it, but it would be better off using Pascal's triangle to do it. But I do want to show you this formula because we're going to need it for our next, or for a type of problem that we can use here. So this is just the formalized version. This thing right here, this is called the choose function, n choose k. It also sometimes looks like this. And so what it represents is n factorial over k factorial times n minus k factorial. Megan's back. We missed her. Megan, I don't even want to tell you how sad Matt was yesterday. It was rough. He was inconsolable. Tanning, but not on a roof today. Well, I guess that's something. All right. How did the birthday party go yesterday? Dynamic duo's back. I blame an owl for my tardiness. What in the world is this class, bro? It was great. She was so excited she cried. Nice. One of these days I'm not going to join the stream and none of you will know what happened. And you can't do that. You've already established, Matt. You've said multiple times you're always here 24/7. So you can't just not show up. That would make you a liar. Yeah, Cassidy does that a lot. Okay, so we have this theorem. Oh no. Not paste. Let's copy. So let's use this. Keep this over here to look at. But so let's see how we could use this to represent the expansion of x plus y cubed. Yeah, there's a giant owl in my neighborhood, and I was getting a picture because it was stalking my strawberries. Excellent. So if you're someone who missed yesterday, right now we're doing x plus y cubed. We did x plus y cubed. I showed you guys how to do that using Pascal's triangle somewhere. So yeah, we did that using Pascal's triangle. Whenever you're doing these binomial expansions, I would recommend using Pascal's triangle. So if you missed yesterday, go back and check out that video because Pascal's triangle is much, I think, easier to use. But here is another way. This is the more formal way we can do it. So x plus y cubed. So this is the formula. It is a series. So in this case, since this is to the third power, so n is 3. So anywhere in this formula where I see n, that's going to be 3. And k is whatever we plug in. Now it starts by plugging in 0. Remember how series work. We start by plugging in 0, then we'll plug in 1, then we'll plug in 2, and then we'll end by plugging in 3, since n is 3 in this case. Okay, so let's actually write this out. So my first term, if I plug in 0 for k, so that would be 3, choose 0, x to the power of 3 minus 0 is 3, y to the k power, but k is 0. All right, so this is the term if k equals 0. Next term, so now we take this equation but plug in 1. Now, so 3 choose 1. X to the power of 3 minus 1, which would be 2. Y to the k power, which k is 2. Or sorry, k is 1. My fault. In Missouri, we have barred owls, barn owls, northern screech owls, and maybe one more subspecies. Interesting. Then we go through and plug in k equals 2. So that would be 3, choose 2. X to the 3 minus 2 would be 1. Y to the k, so that's y to the second. And then lastly, we'll plug in k equals 3. So 3, choose 3. X to the 3 minus 3 is 0. Y to the k, so that would be y to the third power. Platte County non-KC opens May 3rd. True. Okay, now for this choose function. So 3 choose 0. Now remember what this means. So we have a formula here. n choose k, n factorial over k factorial times n minus k factorial. So we could run through that formula. Also, I guess I should go ahead and show you this. You can easily do that on your calculators. You have an option on your TI-84s. So let me pull that up. So on your TI-84, if you go to Math, and then all the way to the right, there's this PRB, which is probability. So you'll see number 3 right here is that n choose r. That's exactly what we would want. So first we plug in the top numbers. So I'm going to type, whoa. All right, top number is 3, and then math, probability, 0. So that's 1. X cubed, y to the 0 is just 1. I don't really need to write the coefficient of 1. That's just 1. Okay, plus 3 choose 1. So just practicing showing you how you can do that. 3 choose 1 is 3. X squared y to the first. 3 choose 2 is also 3 if you do the math. Y squared. 3 choose 3 is 1. X to the 0 is 1. I don't need to write those then. 1, 1. But plus y cubed. Okay, and there's my answer. That's exactly what we got before. Okay, that is the same steps that we use, or not the same steps, but it's the same final answer that we got way back here. All right, x cubed plus 3x squared y plus 3xy squared plus y cubed. And notice, I mean, again, because those coefficients still end up being the same. If n is 3, if we're doing the third power, then I know my coefficients are 1, 3, 3, 1. So that same pattern is still holding up, right? 1, 3, 3, 1. But I think it's easier to go through, and if you can, use Pascal's triangle rather than using this formula for an entire expansion. But it's up to you, I suppose, which one you prefer. We will use this definitely in a second, though. So the next type of problem, our last type of problem that we would see is if it says find the mth term of a binomial expansion. So this m could be any number, like find the 4th term or find the 5th term or find the 12th term, whichever one. If we want to do that, we want to substitute in m minus 1 into the binomial theorem. Okay, now the question is, why would I subtract 1? Okay, what is the point of, if I want to find the 5th term, why wouldn't I just plug in 5? Or if I wanted to find the 12th term, why wouldn't I just plug in 12? Well, if we go back, look at the relationship here. If I plug in 0, that gives me this first term. If I plug in 1, that gives me the second term. If I plug in 2, that gives me the third term. Or if I plug in 3, that gives me the 4th term. So since we always start by plugging in 0, then if we plug in 0, that gives us the first one. So if I want to know, hey, what's the third term? Well, if we look at what's happening, the third term of this, 1, 2, 3, actually came from when we plugged in 2. Okay, so for example, find the 11th term of the expanded binomial. So x plus y to the 17th. Now, what we could do is just do the full expansion and then just count, okay, the 17th term. But if I want to do to the 17th, that's pretty intense. First of all, you would need to go all the way down to n equals 17 for making Pascal's triangle. And that's a lot of work to do. I don't know that you want to do that. I definitely would not want to. I mean, it's not like it's hard. You're just adding numbers together. But all the way down to n equals 17, nah, no thanks. So that's okay because it doesn't ask for the entire expansion. It just says, what's the 11th term? Okay. Well, if the 11th term, if I want to know what the 11th term is, then I can just figure out what happens whenever k is 10. So I don't need to do my series because I just want a single term. So I'm just going to look back at this formula again, the n choose k, x to the n minus k, y to the kth power. Okay, so first up is n choose k. Remember the exponent, whatever the exponent is, that's your n. So n choose k. K is 10. The first term to the power of n minus k, 17 minus 10 is 7. And then the second term, y to the kth power, so that would be 10. And then what does that equal? So x to the 7th, no problem. Y to the 10th, no problem. N choose k, so remember what the formula is. So that's n factorial, so that would be 17 factorial over, right, k factorial times n minus k factorial. So 10 factorial times n minus k, so times 7 factorial. Okay. Now you could actually do the math here. You could also make it a little easier on yourself. 17 times 16. So remember, think of 17 factorial is 17 times 16 times 15. All the way down to times 3 times 2 times 1. Well, think about what's 10 factorial. Well, hey, 10 factorial is right here. 10 times 9 times 8 times 7. That is 10 factorial. Right, so that stuff and the 10 factorial will all cancel. So the numerator is just 17 times 16 times 15 times 14 times 13 times 12 times 11 divided by 7 factorial. Or, again, let me bring up the calculator just so you can see if you wanted to do that on your calculator of 17 choose 10. So type in 17 first, math over to probability. We want the NCR, not the NPR. Okay, NCR, so that's 3. And then 10. So that's 19,448, and then the x to the 7th, y to the 10th. So this would be the 11th term. Right, so it's kind of nice to be able to just pick out a specific term rather than if I don't need to know the entire expansion, but rather just a single piece of it. We can then I would say it's useful to use the binomial theorem. But if you're using to do an expansion, I think it's easier to keep track of things whenever you're using Pascal's triangle compared to if you were just using the formula for binomial expansion. But they both work. Okay, so the big piece though is to remember that whatever the term is that it wants us to find, the k that we plug in needs to be one less than that. So it wanted us to find the 11th term. We have to plug in k equals 10. Okay, so next up, find the 6th term of the expanded binomial. So if I want to find the 6th term, then I know I should plug in k is 1 less than that, so k will be 5. 2c minus 1 to the 14th power, so n is 14. Right? N is always just whatever the exponent is. So let's use our binomial theorem. So n choose k, so 14 choose 5. Right? And then the first term, so it's not just x and y, what the formula means when it says x and y is just whatever the first term is, and then y is whatever the second term is. So our first term is 2c. So 2c to the n minus k power, so 14 minus 5 is 9. And the second term, so negative 1 to the power of k, so that's to the 5th power. All right, so let me bring up the calculator again. 14 choose 5. Is 2002. 2c to the 9th, so what's 2 to the 9th? It's 512 times c to the 9th. And then negative 1 to the 5th, so all that means is since it's an odd exponent, negative, so the negative will stay, so this overall should be a negative term. And now let me just do the math. So negative 2002 times 512 is going to be a rather large number. Negative 1025024 c to the 9th. So this is the 6th term. If I multiplied all this stuff, if I multiplied out that entire binomial, I would end up with this term. It's the 6th one. I would still have a bunch of other terms, but this is the 6th one at least. So sometimes it's nice for us to be able to pick out a specific term instead of going through just a full expansion, especially because, again, n equals 14. I do not want to have to go through and make the Pascal's triangle all the way up to n equals 14. Right? It's just a pain. It's not worth it probably for this problem. Let's do one more. Let's say 3x minus 2t to the 8th. And I want to find the 5th term. Okay, so just looking at the exponent, n is equal to 8. Since I want the 5th term, then that means that k should be 4, because I want k to always be 1 less than whatever the place of the term is. So n choose k, so that's 8 choose 4. The first term of the binomial, so 3x to the power of n minus k, 8 minus 4 is 4. Minus 2t, so negative 2t to the power of k. K in this case is 4. Now, notice that these are the same. That just happens to be a coincidence, but this first one came from doing 8 minus 4. This second one is here just because the actual value of k is 4. So let's calculate. N choose k, so 8 choose 4, 70. Three x to the 4th. 3 to the 4th is 81. X to the 4th is x to the 4th. Negative 2 to the 4th. So negative 2 to the 4th would be positive 16. T to the 4th would be t to the 4th. So I'd end up here. And then lastly, I just want to multiply this stuff together. So 70 times 81 times 16. 90,720 x to the 4th, t to the 4th. Boom. This would be the 5th term of the binomial expansion. So the binomial theorem, the formula is good for, I mean, you can always use the formula if you want to, but it's especially good and necessary if we want to just pick out a specific term. Then we use n choose k, first term to the n minus k, second term to the k. But if you actually want a binomial expansion, and if the exponent's not too large and you can make a Pascal's triangle, or you can use Pascal's triangle reasonably to do it, I would recommend doing it that way. So again, if you missed yesterday's class about Pascal's triangle, I'd recommend that because it's super helpful and much quicker and easier, I think, than trying to do the binomial theorem for an entire expansion. But that's just me. This would be the last thing that you need to know for the sequences and series PFA. Is it'll ask you about expansions, it'll ask you about specific terms, and so you can use again, like I just said, Pascal's triangle, or use the theorem to do it, and that'll be it. Okay, so you can go check that out or go request sequences and series. We've covered that all in class. We still have one more section that we're going to do, or that we're going to learn about tomorrow and Monday, but it won't be on the PFA because it would be, I don't know, I think too difficult to put onto the PFA. So it's not on there, don't worry about it. And then we'll move on, after Monday, we'll move on to our last unit, which is limits. And that shouldn't take a huge amount of time. Also remember, like I said, starting next week on Wednesdays, we no longer have classes. That's a school-wide thing, that on Wednesdays we're not supposed to be giving you new content. It's supposed to be that you can like make like study sessions for like AP exams and things like that if you teach an AP class or something like that. So we won't have streams on Wednesdays from here on out, but that's fine because we don't have that much stuff to get through. We're on a really good pace. We're on a really good time track. So that's all good to go.